All right, here's our bell work. Find the x-intercept for the following equations. Now, the nice thing about x-intercepts is if you were to find an x-intercept, it's always, and this is of course on the graph, but you got your x-axis and y-axis. So if we had a line like, let's say this one right here, the y-intercept is where it crosses the y-axis, like right here, right? And you can see that's always where the x is 0. So if you're looking for the x-intercept, it's where it crosses the x-axis where the y value is 0. So you'd have something like this. So that means that whatever we're looking at here, you're going to have an x value, and then whatever the y value is, it's always going to be 0, okay? Now we know if we replace y value with 0, it really just zeroes out this term completely. Same with this one, right? So that means this first one, you'd end up really with 3x equals 15 because it zeroes out the y's. And then you'd divide both sides by 3 in this case. So this one, you'd say x is 5, right? Now, we don't just write x as 5, we'd write it as 5, 0 because it is an ordered pair in a graph. So the same thing with number 2, you'd have 7x equals negative 21 now. So divide both sides by 7, and you get x equals negative 3. But again, negative 3 isn't enough. We need to show it as a ordered pair, negative 3, 0, like this. So there's our two x-intercepts for these ones. All right, here's our objective. I can write equations in slope-intercept form when I have the slope in a point or 2 points. So take a minute and copy that down, please. So there's 2 different ways to write an equation in slope-intercept form if you've been given the slope in a point or 2 points. And the first method here that we see is solving slope-intercept form for the y-intercept. Okay, so that means you're going to have y equals mx plus b. So you're going to have the m, the x, and the y, but then the b is unknown, which is the y-intercept. And then you solve for the b value. We'll talk about that method here in a moment. But there's also point-slope form, y equals m, x minus x1 plus y1 right there. Okay? So that is point-slope form. Now, in some cases, what they're going to do is they're going to give us 2 points. All that means is that instead of having the m to replace into the slope, either here or in slope-intercept form, we actually have to figure it out using the slope formula. Now, just a little bit about point-slope form, of course. The point means that the point is built into the formula, right? Right. That's the x and y values right there. And same with the slope. It's the m. So that's why it's called point-slope form. So you're going to have these 3 values that you can put into this formula. Now, it's only going to take 2 steps to solve. You're going to distribute the m and then combine your like terms. You'll see that it simplifies immediately in the slope-intercept form with just 2 steps. And even slope-intercept form, if we use the first method there, what's going to happen is it's going to take 2 steps to find the y-intercept, and then you just fill it into the formula, just like we've been doing. All right, so here's our first example. Write the equation in slope-intercept form for a line that goes through 0, negative 5, and has a slope of negative 6. All right, so we're gonna use both methods on this one. Okay, so I'm going to start with the first method, which was to use slope-intercept form. All right, so in slope-intercept form, y equals mx plus b. M is the slope, and b is the y-intercept. We just need to figure out what they are, and then we can fill it into this formula, right? Now, this one was very nice of them, very generous. They gave us the slope right here as negative 6. Okay, so I can fill that box in right now. Now, by using slope-intercept form, here's what I mean, right? So this is slope-intercept form, y equals mx plus b. Now, again, we need 3 of these 4 values in order to solve for any missing value. So if I say, well, I know the slope, which is negative 6, and that's good. We do know the slope is negative 6. It was given up here in the information. But we also know an x and a y value. All right, so I'm going to take this x and y value in the formula and replace them with the x and y values they gave us. X is 0 and y is negative 5, just from that word pair. So I replace the x with 0, the y with negative 5, and then it becomes an equation that I can solve. So I'd say, well, 6 times 0, that's 0, right? So now I got negative 5 equals 0 plus b. Now I can make that a phantom 0, which is very nice, because then it's just b equals -5, and then I have my y-intercept right there, the b, at 0, -5. So I could fill in that slope-intercept form now with -5 here, okay? Now that's the formula, or the slope-intercept form of the line, y equals -6x minus 5, okay? So that was the first method we saw. The second method was to use point-slope form. And why are we using point-slope form? Because they gave us a point and a slope that we need to then write in slope-intercept form. So it would have y equals m, x minus the x value plus the y value. Okay, so it's m, I'll say x1 and y1 like this. That just means it comes from that ordered pair. Okay, so I can start replacing these values with the values they gave us. Okay, so let's see, the m value, of course, there is -6, the slope. Then the ordered pair was 0, -5. Now I write that as -5 in the formula. So I have the slope, and I have an ordered pair 0, -5. From here, again, it's just distribution, combine like terms, and you'll have slope-intercept form. So I would say I'm going to distribute my -6 here, right? So that's -6x, -6 times x, that's the first distribution. The second distribution is -6 times -0, which is still just, well, actually that's 0. You can put -0 plus 0, it's not going to make a difference. And then we got the -5 right there, the -5. So y equals this, right? So that's the one step, distribute. The second step here is to combine like terms, and it will change it immediately into slope-intercept form. So I got y equals -6x. The two like terms that I have here are 0 and -5, which gives us -5. So we can see that this equation that we got from slope-intercept form is exactly the same as point-slope form, right? It's just the method was different. Now, some of you noticed that the y-intercept, actually it was given right here, right? And 0, -5. So all the calculations we just did may not have been necessary, but you can see that you can still use these two strategies to change them into slope-intercept form, okay? So as we do these problems on this worksheet, I'm just going to be alternating between these two strategies. I'll do slope-intercept form and then point-slope form. Slope-intercept form, point-slope form. Okay, but I'm not going to show both on all the strategies, on all the problems. But know that it doesn't matter which strategy you use, you're going to end up with the same slope-intercept form equation anyways. So write this equation in slope-intercept form. It goes through that point 2, -3, so there's our point. And it has a slope of -7/2. So alternating between the two strategies, I'm going to start with slope-intercept form. The slope-intercept form strategy. And again, if you're like, man, I really hate that slope-intercept form strategy, Mr. Sal. Okay, don't use it. You can use point-slope form. We just want you to know that you're going to end up with the same answer either way. Okay? So slope-intercept form, of course, you're looking at fill-in blanks, right? Y equals mx plus b. The m, the coefficient of x, is the slope. The plus b is the term, is the y-intercept. So again, we're going to use the same formula to find the y-intercept, because this one, right, the x value is not 0 anymore, so we couldn't say immediately that this is the y-intercept. So I've got to use this ordered pair in this formula, right? I've got an x value that's 2 and a y value that's -3. So I could replace right now the x value with 2, and the y value also gets replaced with that -3 right there from that ordered pair, okay? X and y value. And we also know the slope. So I replace the slope. It was given to us as -7/2. And then this becomes an equation that we're solving for b. So put this in the calculator, -7/2. Use the n over d button. Times 2. We get -7 out of that. So after simplifying that, we get -3 equals -7 plus b. And now, so this is the second step, right? I said there's going to be two steps. We're going to get rid of that negative 7, zeroed out, I mean. And to do that, I would have to add 7, right? But if I do it to one side, I must do it to the other side as well. So that will zero out, negative 7 plus 7. Well, we also have negative 3 plus 7, which is positive 4, and that's our b value, okay? So up here in slope-intercept form, the b value, it's positive 4, so I would write it as plus 4. We already knew the slope was negative 7 over 2. So that's it. That's slope-intercept form of this line that goes through the point 2, negative 3, and has a slope of negative 7 over 2. And again, 2, negative 3 would make this a true statement. If you replace x with 2, y with negative 3, you'd get a true statement, which is why we're able to use it in slope-intercept form just to simply solve for b at that point. On this one, we'll use point-slope form, but write the equation in slope-intercept form, a line that goes through 2 points, 1, negative 1, and 3, negative 4. Okay. Now this one does not give us a slope though, right? So we need to solve for the slope. So I got m equals, that's the m is the slope. Remember, it's y minus y all over x minus x. So y values in the numerators, x values in the denominators, okay? And the first ordered pair I get is 1, negative 1. I'll put that in green. So the x value is 1, it goes in the denominator. The y value is negative 1, it goes in the numerator. See that ordered pair, 1, negative 1, how it fits into the formula. But the same is true with 3, negative 4. I'll do this one in orange. X is 3, y is negative 4. So the x value goes in the denominator, it's 3, and the y value is negative 4, it goes in the numerator, right there. And again, they fit together, they correspond with each other. X, y, x is in the denominators, y in the numerators. And the nice thing about the calculators we have here is you can use that n over d button to just simply solve this. Okay, so you push the n over d button, negative 1 minus negative 4. And remember, the minus and negative buttons are different buttons on the calculators. And then in the denominator, you type in 1 minus 3. Okay, so that gives us 4 over negative 2, looks like, so negative 2. No, that's not 4 over negative 2. It's negative 3 over 2, right? I did that wrong in my head. Yeah, 3 over negative 2. Yep, so it's going to be shown as negative 3 over 2. That's our slope. And I said I'm using point-slope form this time. And yeah, the m is the coefficient of that parentheses there. And I always just use the first ordered pair when they give us two ordered pairs, right? So I'm looking at 1, negative 1 in that ordered pair. So the slope, right now, we know is negative 3 over 2. The ordered pair I'm using is x is 1, and the y value is negative 1. So this is how it sets up. And again, after 2 steps, we'll have our slope-intercept form. So I would distribute my negative 3 halves into the parentheses. Negative 3 halves times x is negative 3 halves x. Negative 3 times negative 1 would be positive 3 halves. And we got that minus 1 there. And this is what y equals. So again, that's one step. The second step will simplify this. The negative 3 half x does not have any common or like terms to combine with. But we do have the 3 halves minus 1. And if you type that in the calculator, again, just use the n over d button. 3 over 2 minus 1, you'll get a positive 1 half. Okay, and again, those 2 steps change this into slope-intercept form for us pretty quick. So yeah, there's going to be problems like this one where it does not give us a slope like the previous 2 problems. That should be okay. If we don't have the slope but we have 2 points, just use the slope formula to find the slope. All right, write the equation in slope-intercept form of this line. It goes through 5, negative 5, and 1, 4. So on this one, we're going to be using slope-intercept form. But this one does not give us the slope either, so I got to find the slope first. Okay. So I got my first ordered pair, 5, negative 5. So x is 5, y is negative 5. X in the denominator, y in the numerator. And the other ordered pair I have is 1, 4. X is 1, y is 4. X in the denominator, y in the numerator. And again, this is, if you just use the n over d button, you can type this in pretty much exactly like we see it, which I think is pretty convenient. This one looks like it would be negative 9 over 4 slope. okay? So in slope-intercept form, y equals mx plus b, I now have the slope as negative 9/4, so I could fill in that box, okay? So slope-intercept form, y equals mx plus b, and we know the slope is negative 9/4, but we do not know the y-intercept, so I'm going to have to put plus b. And again, I'll use the green ordered pair for this one. I just always use the first one. So the x value in this ordered pair is 5 right there. And the y value shows it's negative 5 in that same ordered pair, right here. So then it becomes this equation, negative 5 equals negative 9/4 times 5 plus b. And again, just solving this, negative 9/4 times 5, I'd get negative 45/4. And this would then equal negative 5. But yeah, we gotta have the plus b right there. And then I need to zero out that negative 45/4. So I would add 45/4 to it to zero it out. But if I do it to one side, I gotta do it the other side. Okay, principles of equality stuff. That's gonna zero that out. So I got negative 5 plus 45/4. Yeah, 25/4. That's positive too. Again, just use a calculator to make that calculation. Since it's positive 25/4, we'll write it as plus 25/4 in the equation. And there we go. We got it. Slope-intercept form of the line that goes through 5, negative 5, and also 1, 4. Now you may be wondering, well, could you use the orange ordered pair in this and then solve for b? Yes, you could. If you did, you'd end up with the same answer, in fact. And again, that's because the y-intercept doesn't change. Same with the slope, right? So whether you use either one of these ordered pairs, it'll still work. Write the equation in slope-intercept form for a line that goes through negative 1, negative 5, and also 1, 1. No problem. But no matter which method we use, we are going to need the slope. So I'm going to use the slope formula. And the first ordered pair I have is negative 1, negative 5. So x is negative 1, it goes in the denominator. Y is negative 5, goes in the numerator like this. But we also have the ordered pair 1, 1. So x is 1 in the denominator. Y is 1, goes in the numerator. Just type this into the calculator. Again, you can solve it by hand if you'd like. You're going to get the same answer either way. So that'd be, it looks like it'd be positive 3 rather. So that's our slope. So I use slope-intercept form on the last one. I'll use point slope form this time. Like this. All right, so I replace the values. I know the slope is 3. So I'm going to replace the m with 3 there. And then I'm using that green ordered pair, which is negative 1, negative 5. So x is negative 1. And the y value is negative 5. So just replace those values respectively. Now, before I do any calculations, if I see any minus negative business on something like this, because I can't just simply type this into a calculator, I would change that minus negative 1 into a plus sign like this, okay? Which is going to, it just simplifies it a little bit for us. And then I'd be looking at distribution, right? So 3 times x is 3x. 3 times 1 is positive 3. Still got the minus 5 there. So that's what y equals. And again, that's one step. The second step will solve this. I got the 3x term. There's no other like terms to combine with it. But 3 and negative 5 can combine to be negative 2. So we see then that the slope here is 3, which we already knew. That'd be like 3 over 1, right? If we were to put this on a graph, it'd be up 3 to the right 1. And then the y-intercept, again, we wouldn't write it as just negative 2. It'd be 0, negative 2. But in the equation, it's fine as is, okay? But that's just a quick review on what we did last time. If you're looking to take an equation and wanted to put on a graph, you'd need those 2 bits of information. So slope-intercept form again, just choose which method you like and then use it, which means like if you like point-slope form, I'm going to be using slope-intercept form on this one. Just ignore the method that I'm using and use point-slope form yourself. And once again, they did not give us the slope, so we're going to have to figure that out on our own using the slope formula. First ordered pair I get is negative 3, 4. So x is negative 3, y is 4. X is in the denominator, y is in the numerator. And the second ordered pair I get x is 5, y is negative 2. X in the denominator, y in the numerator. And again, just use the n over d button to solve this one. So we get 16 over negative 8, so that'd be negative 2, it looks like, as the slope. And remember, if we were putting this on a graph, that means it would go down 2 to the right one from each point on the graph. But we now need slope-intercept form, right? So y equals mx plus b. And we just found the slope, so I can fill that box in for my slope-intercept form. And even when solving it, I know the slope now is negative 2. Now, just to show that it doesn't matter, I'm going to use the second ordered pair, 5, negative 12, where x is 5, so I'll replace that in the formula. I'm using the orange pair there. And then the y value is negative 12. Okay, so when I solve this formula, I'm going to get the same y-intercept no matter if I use negative 3, 4 or 5, negative 12. So solving this, negative 2 times 5 is negative 10. So I got negative 10 equals, negative 12 equals negative 10 plus b. Then just add 10 to both sides to zero that 10, negative 10 out. But if I do it to one side, I got to do the other side. Negative 12 plus 10 is negative 2, and that is our b. So we just put that into the box. And we now have slope-intercept form. Slope is negative 2. Y-intercept is 0, negative 2. So once again, we get the same problem with this one. There's no slope, so we're going to have to figure it out on our own. And we'll use the slope formula. So x is 4, y is 5. So x is 4, whoops, backwards. X is 4, y is 5. 4 in the denominator, 5 in the numerator. X is in the denominator, y is in the numerator. Second ordered pair is 3, 5. X is 3, and the y value is 5, so it goes in the numerator like this. And once again, just put this in the calculator. And this one will be a little bit unique because the slope now is 0. But it really shouldn't be a problem still. Yeah, point slope form this time. And we found our m, which goes in front of the parentheses, and that's 0. And I'll use the green ordered pair this time, 4 and positive 5. Okay. Well, distribute your 0 into the parentheses like this. You get 0x. 0 times negative 4 is, it's still 0. Then you got the plus 5 there. So y equals 0x. And yeah, there's no other like terms with the x's, so we still have a 0x term. But 0 plus 5 there is going to be positive 5. Okay. And again, just real quick, in ninth grade, they're going to say, we'll make that 0x just a phantom 0 and write it as y equals 5. But for the purposes that we're looking at, we want to see it like this. Okay, because you're going to have 2 boxes to fill in the assignment, so that's what we want you to do. Now, just real quick, what this means also on a graph, if we kind of relate it to what we did last time, we got an x-axis and a y-axis. So we're saying y equals 0x plus 5, and we know the y-intercept would be 0, 5, right? 1, 2, 3, 4, 5. A 0 slope just means it's a flat line right here, okay? So the line would look something like this. So that also means that when you see examples like this where it's just y equals a number, it's a flat line, and you just find this number on the y number line or the y-axis, and then just make a horizontal line there. Boom, there it is. So yeah, 0 slope will give us a horizontal line. So on this example, we'll see a unique situation here as well. Again, you don't have the slope, so you should find it first. X is negative 6, y is 4, so negative 6, 4. That ordered pair goes in to the formula. But also x is negative 6 and y is negative 18, the second ordered pair. Now when you type this one in the calculator, it's going to tell you something which is a little different. It's going to say it's like a divide by 0 error, or just errors sometimes. What that means is that the slope is undefined. Okay, it means the slope is so big, we can't even quantify it mathematically other than just to say that it's undefined. Which also means that for this line, we're dealing with a vertical line. Okay, so a vertical line, if we were to look at the graph, an example of a graph, right, we got an x-axis and the y-axis. It means that we should have a vertical line. Well, where would we put that vertical line? In order to figure that out, you just look at the x values, and then it will tell you where on the x number line to put the vertical line. So see how that's -6? So on the x-axis, the x number line, I would find -6, 3, 4, 5, -6 right there, right? And then it would just be a straight vertical line right at that point. Okay? Now that helps us with the graph, but what is the equation? Well, we can't write it in slope-intercept form. Since it's a vertical line, it doesn't have a y-intercept because it's parallel with the y-axis. So it ends up being one of those equations where it's x equals, and again, you're just looking for what the x value is in the ordered pairs, -6, and you're done. So just real quick, parallel lines. The only thing we need to know about parallel lines right now is that the slopes are exactly the same. So if I said we got two parallel lines, and hopefully that kind of makes sense. And we just had some parallel lines. So if I had a graph like this one, x-axis, y-axis, if you had a line like this one right here, a parallel line, we can see that the slope or the steepness does not change. Now if we think about this in terms of the y-intercept does change, okay? So parallel lines, the main thing we need to know with the problems we're going to be looking at is that they have the same slope, okay? All right, so in this problem, write the equation in slope-intercept form for a line parallel to y equals -4x minus 4, but it goes through a different point, right? So right here, we'd say, well, it's parallel to this equation right here. Well, what was the slope of that equation? -4. So parallel slope is exactly the same. It's going to be -4 also. But it's going to go through this point, 8, -3. So I'll use slope-intercept form on this one, okay? Y equals mx plus b. Yeah, we could fill that box in right now with -4 there. We just need to find the y-intercept. So using slope-intercept form, y equals -4x plus b. And yeah, we have our y and x values from the ordered pair up there. 8 is the x value. And -3 is the y value. I'm looking up here at the top. Okay, and then we just solve this for the b value. So -4 times 8 is -32. So we got -3 equals -32 plus b. Well, then just add 32 to make that a 0. But if I do it to one side, I need to do it to the other side as well, like this, okay? So -3 plus 32, that's going to be positive 29, it looks like. That's going to 0 out, and that's b. So that's positive 29, so I'd put plus 29. And there it is. I found the slope-intercept form of a line parallel to y equals -4x minus 4, but it goes through the point 8, -3. Now looking at perpendicular lines have opposite reciprocal slopes. So opposite has to do with whether it's positive or negative, and then reciprocal, remember that just means it's going to flip the fraction, whatever the fraction is. Okay. So if I looked at just some fraction, right? Like let's look at, I don't know, common one like 3/4, okay? If I took the opposite reciprocal doesn't matter which one I start with, but I would know that that's a positive 3/4, which means that the opposite will then be negative. And then reciprocal means I'm going to flip these, the numerator and denominator, so now it's 4/3, okay? And yeah, it goes both ways. 3/4 would be the opposite reciprocal of -4/3 also, okay? So as long as we know the slope from either the equation or 2 points or something like that, if it asks for perpendicular lines, take the opposite reciprocal of the slope. And then you're using point slope form or slope-intercept form to simplify whatever information you have in the slope-intercept form, okay? So let's do that example. Write the equation in slope-intercept form for a line perpendicular, so again, that's an opposite reciprocal slope, to y equals 4x minus 5. But it goes through the point 39, right? So see, this slope is 4. Now I need a perpendicular slope though, okay? So if I took 4 and I wanted the opposite reciprocal, I would look at it really as 4 over 1 like this. So since it's positive, I would then make it a negative, and then I would flip these two to make it 1/4. So now our new slope for the parallel line is negative 1 over 4. All right, so, and as soon as we know this information, all we need to do is use either slope-intercept form or point-slope form. So last time I did slope-intercept form, this time I'll use point-slope form. And we just found the slope is negative 1/4. And it's going through this ordered pair, 3, 9. So x is 3, and the y value is positive 9. All right, so I would distribute the negative 1/4. So that's a negative 1/4 x. Negative 1/4 times negative 3 is positive 3/4. And then, yeah, we got that plus 9 there. So that's what y equals. And the second step will change this into slope-intercept form. Y equals negative 1/4 x. And the 3/4 plus 9, looks like that'd be 39/4. And so our y-intercept, even though it's fractional, that's okay. But that is slope-intercept form of a line perpendicular to y equals 4x minus 5, but it goes through the point 3, 9. All right, so there's our objective. Hopefully you feel very comfortable about writing equations in slope-intercept form if you have a slope and a point and 2 points, even if those are parallel or perpendicular lines, okay?